Electric field due to system of charges. To find electric field due to system of charges, we are going to use the principle of superposition, which says the electric field at a point due to a number of charges is the vector sum of all the electric field at that point taken at one time, or all put together taken at a time. So to find electric field due to system of charges, let us consider Q1 a charge and P a point, and the distance between these two as R1P. Let us consider another charge Q2 at a distance of R2P from the point P. So P is the point where the electric field due to the system of these two charges has to be found out. So as we have taken Q1 and Q2 to be the two positive charges, so the electric field at point P due to Q1 should be 1 upon 4 pi epsilon naught Q by R squared into R cap, which is a general formula. I'm going to apply this to find electric field due to Q1, which we will call it as E1. Therefore, E1 should be given as 1 upon 4 pi epsilon naught Q1 upon the square of the distance, which is R1P the whole square into R1P cap, which shows the direction of electric field, where R1P cap is a unit vector. Next, the electric field at point P due to Q2 should be in the direction as shown in the diagram, and we will call it as E2, where E2 is 1 upon 4 pi epsilon naught Q2 upon R2P square into R2P cap, which is again showing you the direction of E2. Now it is seen E1 and E2 are moving in different directions, so we will use principle of superposition to solve this. When we have two vectors moving at different directions but originating from one point, you can use law of parallelogram of vector addition. So we'll construct a parallelogram with respect to E1 as well as E2 and draw a diagonal from the origin from where the two vectors are coming. So this shows you the diagonal, which is going to give you the resultant electric field. Now this resultant electric field E is given as E1 plus E2, which should be 1 upon 4 pi epsilon naught Q1 upon R1P square, plus 1 upon 4 pi epsilon naught Q2 upon R2P square, along with the unit vectors respectively. So I get resultant electric field at that. Now generally for system of n charges, the resultant electric field at point P is E is equal to E1 plus E2 so on up to En. So whatever number of charges are given, you can add them to get resultant electric field. Or you can even write this as 1 upon 4 pi epsilon naught Q1 upon R1P squared into R1P cap plus 1 upon 4 pi epsilon naught Q2 upon R2P squared into R2P cap, and so on up to n number of charges, which has to be 1 upon 4 pi epsilon naught Qn upon Rnp squared into Rnp cap. Find out which terms are common, get the common term out, which is 1 upon 4 pi epsilon naught, and you can directly write it as summation of Qi upon Rip squared into Rip cap, where I has values starting from 1 up to n.